Pressure and non-pressure to
Different.
same or different?
Different.
Why different?
Friction.
There is a friction?
Yes.
Yes, you agree with that, so that I go for that. Normally what we do, the P1 will be equal to P2 if there is no friction. Now we are going to do the find out the friction. P2 will be less than P1. You agree with me?
Yes.
Because loss in friction. So our aim is, the experiment for the first experiment is to find out the friction coefficient. Friction coefficient, that is the CF. We have to find out the friction coefficient CF. So this will be equal to friction factor divided by 4. You just check with your manual, you can understand friction factor divided by 4. Okay, I am going to find out the F with 4 different methods in our experiment, in our laboratory. I am going to find out with the 4 different. One is the experimental. I am going to do the experimental procedure. Second one is I am going to use the Moody chart. I am going to use the Moody chart. And third one is the empirical relations. So what I am asking is, we need to do the experiment and we need to find out the coefficient of friction with the 3 ways. One is the experimental procedure, second one is using the Moody chart, third one is the empirical relationship. There will be a mathematical equation, you have to substitute and we have to find out. And we have to discuss about how we are getting the coefficient of friction with the 3 different ways. How we are going to do the experiment. Okay, so this pipe will be connected with the 2 limbs here. And it will be connected with the manometer. You agree with me?
Yes.
We are finding out. So now switch on the motor and make the water to flow. So that if I find out what is the volume available here for given time, can I able to find out what is the flow rate?
Yes.
Right?
Yes.
Volume per time. So this will be total volume per time. Normally we are going to take 10 liters of water for so many seconds. Clear?
Yes.
Can you able to do how to take the readings? So we are going to open this pump, switch on the pump, we are going to open the valve and we are going to get this. We are going to adjust the valve in such a way that this valve, in such a way that we are going to do for 3 or 4 setup experiments. Clear or not? Okay, so I wanted to, now what is this? I am getting the Q. If I get the volume per time, can I get the velocity?
Yes.
Can I get the velocity V?
Yes, sir.
How we can find out?
Area material.
Area, okay. So Q divided by area. Q already we have. What is the area?
By D.
So cross section area of the pipe. This will be the diameter of the pipe is given. So I know this is equal to pi by 4 d square.
Yes.
Got it?
Yes.
Understand or not everyone? So I know the diameter of the pipe. So I can find out what is the velocity. If I know the velocity, can I find out the Reynolds number?
Yes.
So Reynolds number will be equal to rho V D divided by mu. What is rho?
Density.
We know water density. What is V?
Velocity.
So we have estimated using this relationship. This we have estimated using our experiment. So we have done the experiment, we have found what is the actual flow, then we know the area of the pipe, then we can calculate the velocity. Then if I substitute, can I get the Reynolds number?
No. Dynamic viscosity.
Viscosity is given for you. Huh? Okay. Friends, we are going to switch on the powder. The pump will be running and we are going to collect the water and we are going to take the time for the 10 liters of collection. From that, I can find out what is the volume flow rate.
Yes, sister.
Okay. Once we find the volume flow rate, then I know the area, then can I be able to find out the velocity?
Yes.
Good. If I know the velocity, can I find out the Reynolds number?
Yes.
Right?
Yes.
Okay. If I know the Reynolds number, I have two relationship. If the Reynolds number is less than 2500, that flow is called laminar flow. If the Reynolds number is more than 2500, it is called a turbulent flow. So I have the two formula here in the empirical relationship. CF will be equal to blah 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 equation. It is there in your manual. Use this if the Reynolds number is less than 2100. So CF will be equal to some blah 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 equation. Reynolds number is greater than 2100. So third is over.
Yes.
Understand or not?
Yes.
So if I have the formula here, just go through your manual. I have two formula here. If I know the Reynolds number, can you get this one?
Yes.
This is nothing but 64 divided by Reynolds number. Something. Here is some other values are there. Just look into your manual. That is the third method. I am talking about the third method.
It's the same.
You agree with me or not?
Yes, Mr.
Noora? There is a formula available for you just above your Moody chart. If you see above your Moody chart, you can get this. This is okay or not?
Okay.
Okay. Next thing, I have a Moody chart with you. All of you can have the Moody chart on the table.
Yes.
The Moody chart is given for the Reynolds number versus the roughness value, pipe roughness value, and the friction factor. Please listen to me now. Shada, all of you. Here the Reynolds number is there. Here in this y direction, right hand side epsilon, left hand side friction factor. Now I have the curves here. The curves meant for the roughness value. Roughness value is the value which will be fixed by the manufacturer of the pipe. Who is fixing the roughness value? Who is fixing the roughness value? Manufacturer. So manufacturer say, my pipe is having this much roughness. My pipe is having this much roughness. So the roughness value will be equal to 0.008 something will be there in the manual. It is given. Just check.
Yes.
You have the epsilon value there?
Yes.
Yeah.
Understand or not?
Yes.
Clear? So I can have this one 0.008 somewhere here. So each curve have its own value. This value is for what? Roughness. Understand? Now what I am going to do? You have the Reynolds number value?
Yes.
Do you have a Reynolds number value? Say yes or no?
Yes.
Okay. Draw a vertical line from this. This is my curve for the roughness value. This is the curve for my roughness value. And draw the vertical line. Draw the horizontal line. Can I get the F value?
Yes.
Finish. If I know the F, then CF is nothing but F by 4.
Here it's given the absolute roughness.
This absolute roughness.
And this is the relative roughness.
I'm sorry? Relative roughness. Both are same. Don't worry. I am talking about the epsilon.
Yes.
I am talking about epsilon. In your chart Moody diagram, you will find that this is epsilon, right hand side. All of you getting or not?
Yes.
You have a chart or not? Can you able to see this chart? Can you able to see this chart? Somehow. You are viewing the graph or not?
Yes.
Okay, here this is my epsilon. Here this is my epsilon. Here this is my Reynolds number. Here it is my F.
Yes.
Understand or not? So fix the Reynolds number here, draw a vertical line, you will have the curve, design the curve, draw a horizontal line, you will get F. Understand?
Yes.
Yes.
Okay, so can able to do this one for the Moody chart procedure?
Yes.
We need to have the Reynolds number only, epsilon it is given in the table. Can you able to find out this one? You agree with me or not?
Yes, yes.
Okay. And all of you please listen. I have another method. Please listen here. Please. Delta P will be equal to F L V square divided by 2GB. F L V square divided by 2GB. This is the formula which is available in your model. All of you please listen, please listen. Then you see further. This formula will be there. If I know the delta P, if I know the D whether you know or not.
We know diameter.
You know what is the distance between these two pipes? That is called L.
Length.
This is the length. It is 1 meter almost. It is there. If I know the velocity using this relationship, can you able to find out what is the F is?
Yes, sir.
Then if I know the F, then can you able to do is what is the CF is?
Yes.
That's it. What is delta P?
Different pressure.
What is delta P?
Different
P2
potential
minus.
Yeah, pressure loss. Delta P is the pressure loss. So how will you find out? So we know the H1 value here in that H1 value, H2 value, right? H1 difference H2 divided by rho G is nothing but my this value. Finish. I have the two limbs H1, H2. You understand or not? You are taking the reading H1 and H2. This difference is nothing. What am I not? I don't know. You know the two pipes there?
Yes.
You are taking the H1, H2. The difference is my H. Huh? That you convert into meter. H into 10 power minus 3 will be the meter. Divided by rho G will be delta B. What? Yes, my dear. What we are getting? Shadar, today you are not in correct mode. P equal to rho GH, right? What I have? What I have? So,
I have H from the manometer.
so this formula may be not delta P. This is HL. Head loss. This formula. Just check with you. What is there in the book?
It is
HL or delta P? Pressure drop or delta P?
F.
Head loss.
What is the formula which is given there?
Mr. F equal
Ah,
2G
okay. F equal to
2G D
2GD
HL multiply HL
multiplied by
HL
HL
divide by LV square.
divided by.
LV square. LV square.
Okay, fine. So, hey, how will you find out the HL?
It is equal to Rm.
By this
HL equal to this one. HL will be equal to this one. That is equal to R. We say R. So, what is the difference between H1 and H2 divided by rho G will give H. Understand?
yes.
Clear or not? Okay. So, I will make this one into one group and this one into one group. So, this group will please come. Come.